broiler chickens. Can you hear me okay, Dr. Olmo?
Yeah, I can, yes, thank you.
Okay, good. That's all that matters. Well, everybody else can hear me. I know that. So just to give you a little bit of background on the economic impact of heat stress, in 2003, a study was done showing that heat stress causes an annual $1.7 billion loss in livestock, with $128 million in the poultry industry alone. So how can we study something that has such a great economic impact? Well, what we did was we took a line of commercial broilers, the Ross 708. We subject them to either heat stress or control conditions, isolating the liver samples for further analysis, using transcriptome and metabolome methods. So now a little bit of background on the poultry industry and how valuable it is in this country. Here I have a graph of meat consumption in the United States from 1960 to 2013. Here we have year on the x-axis and million tons on the y-axis. And as you can see here, chicken has been very rapidly increasing until 2003, where it actually surpasses beef as the highest consumed meat in the United States. So this graph here, just to give you an idea of how much we eat per person. This graph is meat consumption per person. Again, we have year on the x-axis, but this time we have kilograms on the y-axis. And currently, humans are consuming about 43 kilograms of chicken per person. And for those of us who don't like to convert, that's approximately 94 pounds of chicken per person per year. So needless to say, this industry is extremely valuable. In 2015, the value of production was $48 billion, with approximately 60% of that, or $29 billion, coming from the broiler industry alone. So, when something affects the industry, such as heat stress, it's important to study it. So, heat stress itself is becoming more important because of climate change. So, according to NOAA, 2016 was the hottest year on record, with the average ambient temperature being up 1.69 degrees Fahrenheit from 1880. One of NOAA's reports also stated that April 2016 was the 4th highest temperature departure among all months on record, and February 2017 was actually the 7th highest. And according to their most recent report, the 2017 January through March period was the 2nd warmest period of that time at 40.3 degrees Fahrenheit, only second behind that same period in 2012. So this is a classic view of the delta change in temperature from 1880 through 2015. And here I just want to point out that you can see for up until 1980, so for about 100 years, it's fairly constant up until here where we see a rapid increase in temperature. This video shows sort of the same thing, but I think it has a little bit better of a shock value. So it shows the temperature anomalies from 1880 through 2015 in 5-year increments. So, yes, okay. So as you can see, it's largely blue, so not too many spikes. There is, once we get to 1940, you'll see it kind of flashes white, you see flashes yellow. But it really isn't until we hit the late 70s, early 80s, where all of a sudden you'll see it change to orange, and then up to currently, where it is now bright red. So it's not this 1 to 2 degree increase in temperature that's the problem for the industry. It's the increase in droughts and heat waves that's going to be affecting the industry. So here we have a slide that shows the cost of heat stress in broilers and layers, which we took from Dr. Lamont's group. Just going to highlight some of this stuff here. We see an increased mortality, a loss of fertility, increase in metabolic disorders such as ascites, lower disease resistance caused by the suppression of the immune system, productivity losses including lower feed conversion ratios as well as inferior carcass quality. And the last one I'd like to point out is add to capital investment. So this one I like to compare to wanting to hold off as long as possible to turning on your air conditioner in the summer, because it gets very expensive to have that running all the time. It's the same thing in the industry. It gets very expensive very quickly to cool these birds. So the more that we can breed into them, the better off we'll be. So now just to talk about some of the effects of heat stress on the liver itself. According to literature, what we see is a decrease in protein deposition as well as lipolytic activity. We see an increase in lipogenic activity, mobilization of glucose, as well as oxidative stress. We also see mitochondrial damage and impacts on the membrane fluidity and stability. Now, it's important to study the liver, especially in the context of a broiler, because the liver is what I like to call the metabolic powerhouse of the body. So all of the nutrients that are being absorbed from the intestines are being shunted straight to the liver, where a large portion of metabolism happens. So it's really important to understand how this tissue is affected by heat stress. So this is a picture of a 26-day-old broiler with the breast muscle removed so that you can see the internal organs. And here I just want to show where the liver is on a chicken. It's in the abdominal cavity just below the heart. And this red circle here indicates where we are sampling from, so the distal end of the left lobe. So now just to give you a little overview on the liver itself. The liver is the largest and heaviest internal organ at 2.5 to 3.5% of the body weight, which in a broiler is about 65 grams at market weight. So the liver is unique in that it also has a dual blood supply. So this picture is, you can see the liver in the upper left-hand corner, the stomach here, and the intestines down here. So the liver has two sources of blood, so 70 to 80% coming from this hepatic portal vein, which is very nutrient rich. The other 20 to 30% coming from the hepatic artery, which is oxygen rich. The liver also experiences a phenomenon called portal streamlining, where the blood from these two sources actually distributes unevenly throughout the liver, with the left lobe receiving more blood from the hepatic artery. And when a colleague of ours, Liang, did a study comparing the right lobe and the left lobes of the liver from our data, he noticed that a big difference appeared to be that there were less mitochondria in the right lobe. Now this could be important for our study, seeing as we're only sampling from the left lobe. So within the liver, there are generally two accepted units of organization. So we have the lobule, which is a hexagonal unit, which is more of an anatomic organization, but more importantly, we have the acinus, which is sort of the metabolic, the more functional unit in the liver. So that is demarcated by a central vein on either side, and two portal triads, sort of creating this diamond-type shape.